Let's take a look at the answers to yesterday's assignment. 13 through 19, all of these can simply be programmed into Desmos. Remember, what we are looking for is the point of intersection. All right, let's start off with number 13. I've already got these pre-programmed. I can see that they do intersect, so I'm going to click on one of the lines, identify it. 3, 4 is the answer. So I'll just write these next to them. Okay, let's go to 15. So let me turn those off. Let's see what this picture looks like. Okay. Now I can see over here to the left-hand side of the screen. I can adjust my viewing window if you like. Here's my answer. The solution is -1, -9. Did I write that backwards? I did. It's -9, -1. I was thinking I wrote that backwards. There we go. Okay, 17 and 19. Let's see what those answers are. Here's 17. Let's readjust my coordinates. All right, that is -1, 2, and number 19. Let's see what that answer would be. Okay, I can see that right there. Yep, -4, 0. Now I think we have one more problem left. Let's check this out. It's a little word problem. So this, you had to look at that picture to be able to do this correctly. So it says you sell small and large candles. Okay, we can see those. The large one looks like it's $6 each, and the smaller $4 each. So this says you collect $144 selling a total of 28 candles. How many of each type of candle did you sell? That last sentence tells us everything we need to know. So thinking we need to assign some variables. How about we make the large candles X and the small candles Y? That should work out pretty well for us. And now what I could do is I can write a system of equations that adheres to this problem. So you may not have known exactly what to do, but I'm going to show you something here. So you collect $144. That should be one of your equations. I'll show you. So the large candles are $6 for every large candle, right? Plus, how much are the small candles? Those are $4 for every small candle. And that would total up to $144 altogether. So there's one of the equations I want to use. Now, if you got stuck, here's the other one. You're selling a total of 28 candles. So if I could write an equation for that, I'll be all set. So the question is, how many of each did you sell? Well, the answer is you don't know yet, right? So what I'm going to say is X represents the number of large candles plus an unknown amount of small candles gives you a total of 28 altogether. Okay, so sorry for the interruption there. So there's the two equations. The first one represents the money that has been collected. The second represents the total of the items. Now, just take 1 second to talk about this. If you have two variables in a problem, you need two equations to get the solution. If there were three variables in the problem, you would need three equations and so forth and so on. The key to this is one equation represents money, the other equation represents total items. And you can't mix those two things up. It would not work. But in each equation, the X represents the number of candles, the Y represents the large ones, and the Y represents the small ones. Let's go ahead and graph these two. And you can see I've already got this programmed in. All right, so I went ahead and activated that, but I don't see anything. So maybe I need to zoom out to find out where these two, now I'm starting to see something. Here we go. I'm going to go ahead and find that solution, and it is 1612. Now we got to go back to this situation, 1612 as an ordered pair. Now, what we got to remember is that the X were my large candles. So there's 16 large candles and then 12 small candles to be a solution to this particular situation. And there you go.